Okay, so welcome back. So we talked about what a matrix was, how to find the dimensions of a matrix, what made equal matrix, and the special matrix. So now we're going to look at operations with matrices. And the first ones that we want to do is we want to add or subtract matrices, okay? And the way you do that is just a couple of things. One, you're just going to add or subtract corresponding elements. Now, the only way that can happen, though, is if your two matrices have the same dimensions. If they do not have the same dimensions, you cannot add or subtract because there would be extras left over that would have nobody to be added to. So let's just look at some of these matrices. Let's just go ahead and take W through Z there, and let's find their dimensions. So go ahead and just reviewing dimensions, tell me what is the size of W. Okay, and hopefully you said a 3 by 2. Go ahead and do X. And it is a 2 by 3. Y. It is also a 2 by 3. And Z. 3 by 2. Now again, remember, you can only add if they have the same dimensions. So when I look at this, can I add X to Y? Do they have the same dimensions? And the answer would be yes, they do have the same dimensions. They're 2 by 3s. So when you're adding, if you're adding a 2 by 3 to a 2 by 3, your result is also a 2 by 3. Now, a lot of times what I will do is I will set up my matrix because I know it is a 2 by 3. Okay, so I'll go ahead and put my positions down. Do you have to do this? No, you don't. But I think sometimes it does help. With multiplication, it is, I think, a lifesaver if you do that. Okay, and so again, the rule is you're going to add or subtract corresponding elements. Now this one says that we need to add, so I'm going to go up to X and Y, and I'm going to add positions. So this is the 1, 1 position to the 1, 1 position. So 24 minus 15 would be 9, and it would go in the 1, 1 position. Okay, then I have the 1, 2 position, negative 8 plus 29, so that would be a 21, again, and that would go in the 1, 2 position. So we've got a negative 3 and 17. So we're going to add those together. That's going to give me 14. And again, that would go into the 1, 3 position. So go ahead and finish out that matrix addition. And your answer should have been 5, 1, and a negative 19. Okay, now let's look at Z and W. Z and W. Can I add Z and W together? And yes, I can, because they are the same size. So they are both 3 by 2s. Now the thing you have to be careful with here is do watch the direction. So it's a 3 by 2. So it says to take Z minus W. So do be very careful. Now you can rewrite these if you would like. They don't quite give you enough room here to rewrite these, but it's definitely always an option to rewrite those on there. So we are going to take Z. So a negative 3 minus a negative 1. And if you need to write it out to the side, you can definitely do that also. So I'm going to get a negative 2. Now, here's the other thing about it, guys. Matrices are very similar, not exactly the same, but very similar to just your real numbers and how they work. And addition is commutative and associative, both of those, but subtraction is not. Just like with real numbers, subtraction is not commutative, subtraction is not associative. The same way here, and that's why you do have to be careful that you subtract z minus w, not w minus z. Okay, next one is a negative 2 minus 9, which would give us a negative 11. And again, if you look, watch positions where I'm putting my answers. Okay? And then again, I'll let you go ahead and finish that out real quick. Okay, so we're going to go ahead and look at 13. We'll check 12 in class and make sure you got that right. But number 13, it wants you to do W and X. Can you do W and X? And the answer is no. Okay, and what you say is that it is undefined. Okay, we can't do it. Okay, it's undefined. And then let's try number 14. How about X minus Y? Can I do that one? And the answer is yes, I can. Those are both 2 by 3s. So again, we're going to set that up. It is a 2. Whoops, I got that a little too big. 2 by 3. Okay? And so I'll let you finish that out on your own.